Hi everyone, in this video we are going to practice calculating formal charges. It's going to be very, very exciting. Alright, it's not, but that's okay, stick with me here. Alright, so for our very first example, what we're going to do is try to draw out PF3. So the first thing you need to do is draw out that Lewis structure. Once you have a proper Lewis structure, you're going to evaluate it by using formal charge. So what I want you to do is actually calculate the formal charge for all four of those atoms. So for the phosphorus and then all three of those fluorines. Go. Alright, did you get an answer? Hopefully you did, and the first thing that you absolutely had to do was draw out a proper Lewis structure. So hopefully you were able to draw something like this, and the actual geometry of the structure doesn't matter yet. Eventually it will, but we're not there yet, so don't worry about that. And so this is what the proper Lewis structure should look like. And so once you've done this, what you would do is go through and calculate your formal charge for each species. So we'll start with the phosphorus. Phosphorus is in group 5, it's directly under nitrogen, and it is touching 1, 2, 3, 4, and 5 different things. So 5 minus 5 gives us 0. So the formal charge of phosphorus is 0. So that's a really good sign. That's a positive thing that we're on the right track, at least for evaluating our structure. Now, if you notice, all three of those fluorines have the exact same structure. They each have 3 lone pairs on there, and then they're attached through a single bond to that phosphorus. So we really only have to do this calculation one time. So our fluorine is in group 7. It's a halogen, so it definitely wants to have 7 valence electrons, but we need to go through and evaluate how many it actually has. And so we have 1, 2, 3, 4, 5, 6, and 7. That's a great sign. So 7 minus 7 gives us an overall formal charge of 0. Another beautiful sign. 2 formal charges of 0 is a very, very good thing. We are very likely to have the proper Lewis structure, and it is correct. So that's good. All right, so let's try another one. So for this example, I've actually drawn out a structure for you, and all I want you to do is just determine what the formal charge is of each of those atoms as is. Don't add any lone pairs. Don't remove any bonds. What are the formal charges of each of those atoms? So pause this really quickly. All right, did you get an answer? Hopefully you did, and so I'm hoping this is something that is starting to become kind of quick for you, that once you have a structure, you can just fly right through. The hardest part is probably locating each one of these atoms on the periodic table, but once you've done that, the rest is pretty straightforward. So for this sulfur, it's in group 6, it's directly underneath oxygen, and now this sulfur is touching 1, 2, 3, 4, 5, and 6 different things. So 6 minus 6 gives us a formal charge of 0. This carbon is definitely in group 4, and it's definitely touching 1, 2, 3, and 4 different things. So 4 minus 4 again gives us a formal charge of 0, so that's good. And now we can do this nitrogen for our last one. Nitrogen is in group 5, so it wants to have 5 valence electrons, but it's touching 1, 2, 3, 4, 5, and 6. So 5 minus 6 gives us a formal charge of -1. So the 0 on the carbon is very good, the 0 on the sulfur is very good, the -1 on the nitrogen is okay, it's not the best thing, but if you have a 0, 0, and a -1, that's probably going to be the best structure. And for this example, it actually is. There's an overall charge of -1 on this molecule. All right, let's try one more like that where I've given you the structure. And so for this one, again, I just want you to evaluate it and determine the formal charge of each atom. Don't add anything, don't draw anything, and then make sure you go ahead and pause this video right now before it goes away for the question. All right, did you get an answer? Hopefully you did, and hopefully one of the first things that you notice is that both of these chlorines are drawn in the exact same manner. So they each have 3 lone pairs and 1 single bond attached to a sulfur. So we really only have to do the math for the chlorines one time. So chlorine is a halogen. It means it's in group 7. It wants to have 7 valence electrons around it. Now each of these chlorines are in fact touching 7 things. 1, 2, 3, 4, 5, 6, and 7. So 7 minus 7 gives us a formal charge of 0 for each one of these, okay? So now we can do our formal charge for our sulfur. Sulfur is in group 6. It's directly below oxygen, and so this sulfur is touching 1, 2, 3, 4, and 5 things. So 6 minus 5 gives us an overall charge of +1, so we have a +1 right here on that sulfur. Now we can go to our oxygen right here. Oxygen is in group 6. It's directly above sulfur, so it wants to have 6 valence electrons. This one has 1, 2, 3, 4, 5, 6, 7 valence electrons, so 6 minus 7, or 7 electrons around, excuse me, 6 minus 7 gives us an overall charge of -1. So this oxygen has a -1. So if we were to write out SOCl2, we would see that the -1 on the oxygen and the +1 on the sulfur combine together to give an overall charge of 0, which is correct. So this is perfect. All of our formal charges add up to give us the correct total number. All right, so now this last one is a little bit different. I've never done a problem like this with you before, so hopefully just take a second and kind of take it all in. So I've drawn 3 different structures for you, and so one of these is the best Lewis structure, and I need you to determine which one is the best one. And the best way to do that is by using formal charge. So very quickly, make sure you pause this video so that you can write down all these structures so that you can actually calculate the formal charge before the question pops up. All right, did you get an answer? Hopefully you did. This one definitely took a little bit more time, so we're going to work through this very slowly. The first thing that I want to point out is that all three of these fluorines around this molecule on the left are the exact same. They each have 3 lone pairs and a single bond to the bromine, so we only have to calculate these fluorines once. So fluorines in group 7, it's a halogen, so it wants to have 7 valence electrons. It is each touching 7 things, so 1, 2, 3, 4, 5, 6, and 7. 7 minus 7 gives us an overall charge of 0. Now we can look at this bromine here. Bromine is also a halogen, also in group 7. It wants 7 things. It actually has 1, 2, 3, 4, 5, 6, 7. 7 minus 7 gives us a 0. So now this fluorine is a 0, this fluorine is a 0. We know that because of this math right here, and that bromine is a 0. So right away you should be thinking this is a solid structure. All 4 of my atoms have a formal charge of 0. It's really hard to beat that, okay? So hint, hint. But let's go through each one of these just for practice now. All right, fluorine over here. Same math as before. 7 wants 7 things, touching 7 things, definitely a 0. That's the same for this fluorine right here and this fluorine right here. So I'm going to try to just go quickly here. Now this fluorine right here at the top is a little bit different. Still in group 7, still wants to have 7 things, but this one is touching 1, 2, 3, 4, 5, and 6 things. So 7 minus 6 gives us an overall charge of +1. So that fluorine has a +1 charge on it. Now this bromine is in group 7. It wants to have 7 things, but it's touching 1, 2, 3, 4, 5, 6 things. So 7 minus 6 gives us an overall charge of +1 as well. So +1. So for this molecule, it has an overall charge of +2, which is a bad thing. That's not a positive thing. This is probably not the right structure, okay? Moving on, we have one more over here. All right, so this fluorine, we've already calculated same math as right here, but let's do it again quickly. It wants to have 7 things. It's actually touching 1, 2, 3, 4, 5, 6 things. So 7 minus 6 gives us an overall charge of +1. Same math as right here, +1. And this bromine's the last one we need to do. It is in group 7, it's a halogen, so it wants to have 7 things touching it, but in fact this one only has 1, 2, 3, 4, and 5, so 7 minus 5 gives us an overall charge of +2, so this one has a +1 on each of these fluorines, it has a +2 on the bromine, so it has an overall charge of +4, which is just stupid. That doesn't make any sense. Nothing ever has an overall charge of +4. So this is definitely wrong, definitely not the right structure. So even though this is a big mess now, this one on the left was definitely the proper structure and it was drawn the best, and we could confirm that because every single one of those atoms has a formal charge of 0. I hope this makes sense. If not, take some time and just practice, practice, practice. You can always Google formal charge worksheet and something will pop up, and just drill it. Make sure you get all these examples done until it completely makes sense in your head. Have a great week. Take care of yourself and drink water.